In this lesson, we're going to look at unit conversions. We've talked about taking measurements in various units, but the units that we have taken our measurements in, or that we have values reported to us in, are not necessarily the units that we need to actually do our calculations. And so what we need to do is to be able to convert one unit of measurement into terms of another unit, equivalent unit, so that we can make sure that we're comparing apples to apples. So when we are converting units, we can only convert corresponding units. We can convert one measurement of the length of an object, the size of an object, to another unit. So for example, we could express the length of an object in meters or miles or feet or inches or centimeters, but we couldn't use seconds or we couldn't use kilograms or something like that. Those are measurements of different quantities. When we have a physical quantity that we've measured, what we have is a numerical value, but that numerical value is supposed to be connected back to something that's real, and so we can't change that numerical value, because we would be breaking the link of the mathematics that we're doing, and we're breaking the link from that back to the physical object or the physical measurement that we've taken. So we don't want to change the value, but what we can do is to multiply by 1, right? If we multiply by 1, then that's not changing the value at all, even though it may be changing the way that that value is expressed. And so what we can say, for example, is if we look at some distance, and this distance is 1 foot, we can measure that distance in terms of inches, and we can say that it's also 12 inches. 1 foot is the same length as 12 inches because that is our definition, that those two quantities are the definition of how those two quantities are defined relative to one another. So 1 foot over 12 inches, or 12 inches over 1 foot, either one of those equals 1, because this quantity divided by this quantity, these are the same quantities, so they would cancel out, and we get 1. So what we can do then is to do a unit conversion. We can multiply by 1 multiple times to convert one quantity, like a mile, into inches. So we can start with 1 mile, and we want to multiply by 1 multiple times to convert miles into inches. Now, I don't know how many inches there are in a mile. I know how many inches there are in a foot. And I don't know how many inches there are in a mile. I know that 1 mile is 5,280 feet. So what you can kind of see here is that I can't go from miles to inches, but I can go from miles to feet, and then I could go from feet to inches. And so what I'm going to do here is I have this quantity 1 mile. I don't want to change that, but I can multiply by 1 and re-express that in terms of feet. Here I have miles on top, right? Implicitly, there's a numerator. The 1 mile is in the numerator, and I can just arbitrarily put divided by 1 as a denominator. And so I have miles in the numerator. I want to get rid of miles and express it in terms of another value. So I'm going to put my 1 mile in the denominator, and then I have to put 5,280 feet in the numerator, so that this whole thing equals 1. I'm not changing the value, but I can cancel out my mile units, and now I have a value expressed in terms of feet. I don't really want feet either, though. I want inches. So I have feet in the numerator. I want to get rid of that as well. So I'm going to put 1 foot in the denominator, and then I have to make this whole value equal to 1 as well. So 1 foot is equal to 12 inches, and then feet and feet are going to cancel as well. And now I have inches left. Those are my only units, so I have an expression of inches. I have multiplications and division, so those are all on equal terms to one another. Basically, I can just multiply across the top, multiply across the bottom, but my 1 times 1 times 1 just gives me a denominator of 1, so I'm going to just omit that and not worry about that. And so I'm going to end up multiplying 5,280 times 12, and that's going to give me 63360. My units left over are inches. I have a divided by 1 on the bottom here from the denominator. I'm just going to omit. And then my last thing would be to write this in, round this to significant figures. In this case, I have 1 mile. And so Actually, that's not the case. One perfect mile, and then I have these values are all considered perfect as well. These are the definition of a mile, the definition of an inch. So these are all considered to have full significant figures. So this would be the full value of the number of inches in exactly 1 mile. We'll be doing many conversions. The conversions that you should know are the number of feet in a mile, the number of inches in a foot. Those are fairly random numbers, but that's the American system that we use. You should know how many minutes in an hour, how many seconds in a minute, that sort of thing, how many days in a year. I know that technically there should be 365 and a quarter days due to our leap year, but for the sake of simplicity, in this class we're going to assume 365 days in a year. You should also know in the metric system, 1 meter is 100 centimeters or 1,000 millimeters, but all of this is really just using our centi and milli unit prefixes there. To go back and forth between the metric and American systems, I just remember this one value here. 1 inch is 2.54 centimeters. That gives me 3 significant figures there, which is usually sufficient. And then I can do conversions within the American system to give me inches. I can convert inches to centimeters, and then do conversions within the metric system to get whatever other value I'm looking for. So we'll do a few quick examples. Take a moment and pause this video and try to calculate how many ounces there are in 1.3 pounds. Again, 1 pound is defined as 16 ounces. So I start with 1.3 pounds. I want to convert pounds to ounces. And I have a direct comparison between the two, so I don't have to have any intermediate steps. My pounds are in the numerator implicitly, so I want to put 1 pound in the denominator to cancel it out. But I also need this value to equal 1 so that I'm not changing my overall quantity, my overall measurement. So I can say 1 pound is 16 ounces. So now I've eliminated pounds, I've introduced ounces. I'm going to just multiply across the top and bottom. The 1 times 1 is just 1, so I can omit that in the denominator. I'll multiply across the top here. And I get 20.8 ounces. In this case, I have 2 sig figs for my initial measurement, so I need to round this to 2 sig figs for my final value. And so I'm going to go ahead and round this to 21 ounces. Take a moment to consider this conversion. We want to convert feet to meters. In this case, we're going to start with feet, and we want to end with meters. I don't know what the direct conversion is. I do know that this is a imperial measurement. This is a metric measurement, and the only way between those two that I have memorized is I know I can convert inches to centimeters. But looking at it this way, I know that I can convert feet to inches. I can convert centimeters to meters. So that's going to be kind of my plan of action here. I have 2 feet. And I want to get rid of feet and introduce inches, so I'm going to put 1 foot in the denominator to cancel out the feet in the numerator, and I know that 1 foot is 12 inches, so there I've multiplied by 1, I haven't changed the value. Now I have inches in the numerator, I don't want inches either, so I'm going to get rid of inches. I know that 1 inch is 2.54 centimeters, that's the one conversion that I keep memorized. That cancels inches for me, but now I have centimeters, which I don't want either. And so now I can say that I've got 2 different ways I could do this. I could say that 1 centimeter is 1 times 10 to the negative 2 meters. Because that's exactly what the centi means. The centi unit prefix means 10 to the negative 2. I also could have put 100 centimeters is 1 meter. This would be 100th would be the value I'm adding here, or this is 10 to the negative 2, which is also 100th. Either way you want to do that is perfectly fine. It gets you to the exact same answer. In this case, I've canceled out centimeters, and I have my final value in meters. I have all 1s in the denominator, so I'm just going to go ahead and omit that. I'm just going to multiply across the top. And I get 0.6096 meters. 12 inches in a foot is a definition of the relationship between those units. So these are considered perfect numbers. They don't, have infinite significant figures, or you can just omit them when considering significant figures. The same thing here. The relationship between centimeters and meters is a definition as well. This has 3 sig figs, which is usually sufficient for us. We also have 3 sig figs here. So either way, we're going to use 3 sig figs. With a explicit decimal point here, I'm going to start at my first non-zero number and keep those sig figs, and then I'm going to round using the next value, round that up, and I have, this is my final answer. We can use this same basic method even when we have more complicated conversions to do. Sometimes we'll have derived units where we have various subunits that we need to consider, and we can do that separately. So for example, if we want to convert meters per second to miles per hour, this is a distance per time, so this is a speed, that's a derived unit. But if we want to convert meters to seconds, and we want to convert that to miles per hour, we can convert the top, meters to miles. Those are two measurements of distance, so we can convert those directly. And we can convert seconds to hours. Those are both measurements of time, and we can convert those as well separately. Since these are divided, they are independent of each other, and we can just convert one and then convert the other. If I'm going from meters to miles, I realize that those are that is a metric to a imperial conversion, so that's not going to work directly. My only conversion for length between metric and imperial is centimeters to inches. I know that conversion there. I know I can convert meters to centimeters, so that's fine. I really can't convert inches to miles. What I know about miles in particular, they're very large. There's 5,280 feet in a mile, so I can convert feet to miles, and I can convert inches to feet, so I kind of have a pathway there that I'm looking for. If I'm looking for seconds and hours, those are used in both the American and the metric systems. I know that I can convert, I can't convert them directly, but I know I can convert seconds to minutes, and I can convert minutes to hours easily enough as well. So I'm going to do this conversion here, but basically in 2 different steps that are independent of each other. Since we're doing all multiplication and division, I can do them in any order. So if I convert the numerator and then I convert the denominator separately, doesn't matter what order I do them in. Mathematically, that's all allowed. So I can take my 17 meters per second. I'm going to start by converting the top. I want to get rid of meters. And I would say that 1 centimeter is 1 times 10 to the negative 2 meters. That's the definition of a centimeter by using unit prefixes. I know that I want to get rid of a centimeter. I can say that there's 2.54 centimeters in 1 inch. I'm always looking so that I cancel my units there, I cancel numerator, denominator there, but I have to keep the numbers where they should be in each one of the individual definitions of these units. I know that I've got 12 inches in 1 foot, and I know that I've got 5,280 feet in 1 mile. So I got rid of feet, I got rid of inches, and now I have this converted to miles. Technically what I have here would be miles per second, what I have. But I don't want miles per second, I want miles per hour, so I need to convert my seconds to hours here as well. So I'm going to start with the second conversion. I have seconds here in the denominator. I want to get rid of seconds in the denominator, and so I'm going to put those seconds in the numerator, and I'm going to convert seconds to minutes. So I know that I have 60 seconds in 1 minute. And then now I have minutes in the denominator. I want to get rid of minutes in the denominator, so I'll put them in the numerator. And I know that there are 60 minutes in 1 hour. And again, seconds will cancel seconds, minutes cancel minutes. And now my units that are left are miles over hours. At this point, I can just multiply across the top and multiply across the bottom. Remember that these are all multiplication and division. They are all on an equal footing, an equal precedence in order of operation. So your calculator will be able to do all that for you. In this case, you get 38.0279, but we have to go back to our significant figures. I started with 2 significant figures here. Everything else here are definitions, except this one is rounded. That has 3 sig figs. 2 sig figs is my weakest link, so I'm going to count 2 sig figs there, and this will come out to 38 miles per hour. A similar quirk that you may see is when you have squared or cubed units. So if you're talking about an area or a volume, you have to convert each subunit a corresponding number of times. So if you have, what that means is, for example, if you have 1 foot is 12 inches, then that means that you can square both sides, essentially, and you'd say 1 squared foot squareds, or feet squared, I should say, would be 12 squared inches squared. And then 1 squared is still just one. So 1 foot is 12 inches. 1 foot squared is 12 squared inches squared. And where that comes from is the idea that if you have a square that's 1 foot on a side, and it's 1 foot on a side, you're going to have 12 inches one way, and you're going to have 12 inches the other way, and so you're going to end up having 144 inches squared in that area. And so if you wanted to know how many square inches are there in 3 square feet, it's the exact same idea. We have 3 square feet, and we want to convert that to square inches. Well, we know directly the relationship between feet and inches, and so we can say, well, 1 foot squared is 12 squared inches squared. We can cancel out feet squared. We're introducing inches squared. This is still equal to 1 because if this equals that, then you square both sides and they're still equal. You divide anything by itself, it's still equal to 1. And we multiply this out, we end up with 432 inches squared. But again, we go back to our sig figs. We had 3 sig figs to begin with, so we're going to take 3 sig figs here and round this to 430 inches squared. Take a moment and pause this video and try to do this conversion for yourself. Here we have kilometers. kph is kilometers per hour. We want to end up with feet per second. We notice that kilometers are metric, feet are imperial, and so to convert length between the imperial and metric system, we have to convert centimeters to inches. That's the one conversion that I memorize. I can't go from kilometers directly to centimeters, but what I can do is I can go from kilometers to meters to centimeters. And then if I have inches, I can convert that to feet. Time is the same in the American and metric system, so I can't go directly from hours to seconds, but I can go from hours to minutes to seconds. And so I can kind of lay out my strategy here. I'm going to start out with 85 kilometers per hour. I can use scientific notation to represent a kilometer. I can use scientific notation again to represent a centimeter. Always be careful. It's easy to make a mistake to multiply when you should divide, or divide when you should multiply. So make sure that your values are going to get together the way they should, that 1 inch is 2.5 centimeters and not vice versa, and make sure that your units are canceling the way that they ought to. Also notice there is one trick that you can use here. When you're converting hours to seconds, technically you should go through minutes, that there's 60 minutes in an hour, there's 60 seconds in a minute, but hours and seconds are the values that we use the most. And so notice here that 1 hour is really 60 times 60, so really 3,600 seconds is 1 hour. So if you want to remember that, that can save you a little bit of time, but you end up about the same place anyway. So I end up with 77.464. And here I have 2 sig figs. These are perfect. That's 3 sig figs. These are all perfect. So I'm going to round this to 2 sig figs. And I shouldn't have rounded this up and rounded that up. I would round this to 77 feet per second is the answer with 2 sig figs. Take a moment to pause this video and try to do this conversion. Here I have 1.2 square miles, and I want to convert that to meters. I know that miles are imperial and meters are metric, so I know that I'm going to end up having to convert from imperial to metric, and there's only one conversion that I know there. I know I can go from centimeters to meters. I know that I can go, I can't go from miles to inches, but I can go from miles to feet to inches. So in this case, I have 1.2 square miles, and I can say that 1 mile squared is going to be 5280 squared feet squared. I can say that 1 foot squared is going to be 12 squared inches squared. I can say that 1 inch squared is going to be 2.54 squared centimeters squared. And then I can say that there are 100 centimeters in a meter, so there would be 100 centimeters squared in a meter squared. In this case, I'm not going to use the scientific notation, the unit prefix. I'll say that there's 100 centimeters in a meter, and so there'd be 100 squared centimeters squared in 1 meter squared. Again, I want to double check all of my units are canceling out, and I want to double check that I'm multiplying and dividing where appropriate, and then again I can just multiply across the top and multiply across the bottom. The order doesn't matter because multiplication and division are of equal precedence in the order of operations. This gives me the following answer. So I have a very large value here. I have 2 sig figs, so I'm going to round this to 2 sig figs here. And I'm also going to use scientific notation. So I have 3.1 times 10 to the 6 meters squared, so 3.1 million meters squared. And obviously that is, none of these is several orders of magnitude larger.